points are on the arcs of intersecting circles. Let's look at the circle with center C. These 6 points are equally spaced on the arc of circle with center C. So when I draw these radii, these angles are going to be congruent. Let's call these angles alpha. So we'll express the 2 named angles in the problem statement in terms of alpha, and then we'll solve for that variable. We'll start with angle AHG. I'm going to redraw my circle with just the points of interest. Then this angle at C between A and G, this is 3 alpha. And since this is a central angle, the arc from A to G is also 3 alpha, which means that the major arc that goes around the long way from A to G is 360 minus 3 alpha. And because angle AHG is an inscribed angle that cuts off this arc, it's going to be half of the length of the arc. Let's try to find angle ABD. I'll draw another circle that contains this point C. It also has A and E and the other points. This angle ACE is the same as up here between the radii to A and E. That's 5 alpha. Since this is also an inscribed angle for this circle, then we have this major arc from A to E is 10 alpha, and then the minor arc from ACE up top here is 360 minus that. Again, we're interested in angle ABD in terms of alpha. Since these points A, B, C, and D and E are equally spaced, then the arc up here from A to D is 3/4 of the arc from A to E. That's 3/4 of 360 minus 10 alpha, which is 270 minus 15 halves times alpha. This means that the major arc around the other side from A to D is 360 minus this, or 90 plus 15 halves times alpha. That's the arc from the inscribed angle ABD, so ABD is half of that, or 45 plus 15/4 alpha. Now we're given in the problem statement that angle ABD exceeds angle AHG by 12 degrees. So we'll substitute our expressions for these angles in terms of alpha. The one we just found is ABD, and then we'll subtract this angle AHG. And now we'll solve for alpha, and we get that alpha is equal to 28 degrees. Now let's find angle BAG. I'll draw that in here. Let's divide this angle into 2 angles, the one up top BAE and the one at bottom EAG. Let's see if we can find these angles in terms of alpha. This arc EFG is 2 alpha because that's our central angle, and EAG is the inscribed angle for that arc, so it's half of that, or alpha, or 28 degrees. Now we'll find angle BAE, also an inscribed angle for this other circle. It cuts off this arc from B to E. Notice that arc BCE is the same length as arc ABD because each of these points are equally spaced. And we already found ABD here in terms of alpha, so we can substitute 28 degrees, and this is equal to 60 degrees. So our inscribed angle here, BAE, is half of that, or 30 degrees. So we'll add these together, 30 and 28, and our answer is 58. If you'd like me to solve any other contest problems, please leave them in the comments.